We're surrounded by these little electronic brains, right? They're in literally everything from your car to your coffee maker. But here's the thing, they're not all the same. Today, we're going to crack open this world and look at two of the most important components out there, microprocessors and microcontrollers. Let's get into what makes them so different. All right, so here's the plan. First, we're going to go on a little hunt and find where these tiny brains are hiding. Then we'll get to know our two main players, the microprocessor, the big generalist, and the microcontroller, the specialist. After that, we'll put them head to head, a real showdown, to see the differences. And finally, we'll wrap up by talking about why any of this actually matters to you. Okay, let's kick things off with a pretty wild idea. Almost every single electronic thing you own has a secret little brain inside, pulling all the strings. Seriously, just think about it for a second. What's running your car's engine or your microwave? What's powering the very computer you're using right now? It's not magic, right? It all comes down to a tiny piece of silicon. Well, the answer is almost always one of two things, a microprocessor or a microcontroller. And wow, they are just everywhere. We're talking engine control and airbags in your car, the smarts in your washing machine, even life-saving medical devices. Your phone, your smartwatch, all those IoT gadgets, they're all powered by this hidden intelligence. So let's dive in and meet the first of our two tiny brains, the microprocessor. Think of this one as the powerful generalist. So what is a microprocessor, or MPU for short? Well, it's basically the central processing unit, the CPU of a computer. It's the core that does all the heavy lifting, all the calculations and thinking. Its job is high-powered, general-purpose computing. Like the big-shot Intel or AMD processor that's humming away inside your laptop or a giant data server. Yeah, calling it the brain of a computer is a spot-on analogy. Just like our brains handle all sorts of complex thoughts, the microprocessor is the main command center for a computer system. It's built for power, and it's built to juggle a whole bunch of different, complicated tasks at once. But, and this is a really big but, for all its power, a microprocessor is kind of helpless on its own. It's just the brain. To do anything useful, it needs a whole team of other components to back it up. And that support team is pretty big. We're talking external memory chips, like ROM for long-term storage and RAM for its working memory. It needs separate chips for input and output, for timers, you name it. It's like a genius brain that still needs external parts to serve as its memory, its eyes, its ears, and its mouth. Okay, now let's switch gears and look at our second component. This one takes a totally different all-in-one approach. Meet the microcontroller. So a microcontroller, or MCU, is not just a brain, no way. It's more like a whole tiny computer packed onto a single chip. It's not built to browse the web or play games. Instead, it's designed to do one specific job and do it really well inside another device. That's what we call an embedded system. And that's why it has this awesome nickname, computer on a chip. It pretty much says it all, right? This isn't just the CPU, it's the whole shebang, all squeezed into one tiny, efficient package. And that right there is the absolute key difference. Remember how the microprocessor needed that whole external support team? Well, the microcontroller has the CPU, the memory, the I/O, everything built right onto the same little chip. This diagram really shows you what we mean by computer on a chip. Just look at that. Everything is integrated. You've got the CPU right there, but you've also got memory and I/O ports all on the same die. It's designed to connect directly to things like sensors or motors. It is a completely self-sufficient little system. And because it's this neat, all-in-one package, it's absolutely perfect for controlling one specific thing. This is the little brain in your dishwasher that knows exactly when to switch cycles. It's the chip in your thermostat that's constantly checking the temperature. It has one job to do, and it just does it, day in and day out, super efficiently. All right, time for the main event. Let's put these two side by side for a proper showdown. This should really make the differences crystal clear. So in one corner, we have the microprocessor, our powerful, generalist brain. And in the other corner, the microcontroller, our super efficient, specialist mini-computer. Okay, let's go through this. First up, core function. The microprocessor is all about general-purpose computing. It can do anything. The microcontroller, it's for controlling one specific task. Next, architecture. This is the big one. The MPU is just the CPU on a chip. The MCU, on the other hand, is the whole system, CPU, RAM, ROM, I/O, all in one. That directly impacts peripherals. For an MPU, they're all external. For an MCU, they're integrated right on the chip. Now, what does that mean for cost? Well, an MPU system is going to be way more expensive because of all those extra parts. The MCU is cheap and simple. And that, of course, determines where we use them. MPUs go in your PC, your laptop, your server. MCUs are in, well, pretty much everything else. Appliances, cars, you name it. And that really gets to the heart of it. The huge advantage of the microcontroller is just how much it simplifies things. The design costs are lower, you need fewer parts. It's a game changer. I mean, think about it. For the millions upon millions of microwaves and toys made every year, using a cheap all-in-one microcontroller is a no-brainer. You don't need a supercomputer just to blink a light or tell a motor to spin, right? So why does any of this matter? Well, understanding why we have these two completely different approaches is key to understanding the technology that fills our lives. Really, it boils down to two different design philosophies. It's powerful versatility versus compact efficiency. You go with a microprocessor when you need raw power and flexibility, something that can run a complex operating system and juggle a ton of different apps, like your phone or your computer. But you choose a microcontroller when you need a cheap, reliable, and power-sipping solution to do one dedicated job and do it perfectly. At the end of the day, it's all about picking the right tool for the job. And this all leads to a really interesting question for the future. As literally everything around us becomes smart, from our toasters to our cities, which of these tiny brains do you think is going to shape our world the most? Is it going to be the super powerful generalists or the billions of tiny, efficient specialists quietly working away in the background? It's something to think about. Thanks so much for tuning in.
Thanks for watching, and please like, share, and subscribe for such more content and appreciation. Make sure to comment your questions and